Hi, my name is Mohammad Rizwan and I would like to welcome you to this short tutorial on Singleton Design Pattern. I will be going to demonstrate what design patterns are and the significance of considering them while designing our applications. I will discuss in detail one of the most commonly used Singleton Design Pattern, the problem it addresses and the solution it offers to elegantly deal with it. I will then move on and discuss some of the caveats that you as developers should have to be dealt with when considering to use this pattern in your application. So without any further ado, let's get started. So as soon as we hit the ground running with the object-oriented development, we will normally get confronted with a couple of design problems along the way. The object-oriented paradigm does not provide any guidelines on how to be effective in such cases. This is where design patterns comes into play. Think of design patterns as proven tested solutions for common design problems that we all came across at some point during our development. Consider them as suggestions that should be taken into consideration when designing applications to avoid any consequences that may appear sometimes later during the development process. For example, when designing application, if we came across a situation where a single object instantiated from a class could serve the need for the whole application and creating more objects out of it would be resource intensive, then in that case we must need to have some sort of mechanism in place to only allow one object to be instantiated from that class. This is where the singleton design pattern kicks in. This pattern provides us with a guideline on how we could impose restriction on the class to only get a single instance out of it. Of course, if you have some better alternatives, feel free to choose them. Considering the fact that these solutions are battle hardened tested, it is sensible to go with them instead of having to come up with your own suggestions, which could lead to unwanted results. Here I have taken the anatomy of an electricity connection installed in our premises to demonstrate the fact that a single connection is suffice in most cases to operate all electric household appliances. It will never be the case that a separate dedicated connection is established for individual appliances. Neither you will ever come across a situation where the connection is context switching to only supply power to one appliance at a time. Rather, it works seamlessly and serves the need for all installed appliances. Down below, I try to simulate the same behavior using objects and classes. So here I have instantiated a couple of objects that corresponds to the bulb class. These objects contain two methods. One encapsulates the logic to switch the bulb on and the other one to switch it off. But as you might have guessed by now that these methods do not make sense on its own. Instead, it requires the use of some sort of power supply to operate, and for that same reason, we have introduced another class to serve that same purpose. The electric meter class here exposes methods to acquire and release connections as and when required to guarantee that the same connection is provided each time a request is made for power supply. The singleton design pattern have taken the liberty of creating class objects out of the consumer's hand and instead give the class this responsibility of having to come up with its own single instance each time a request is made for the connection. From the consumer point of view, all they have to do is to make a call to the get instance static method and will get back the only instance of that class. We can name the method that provide us with the class instance whatever we want, but by conventions it is preferable to name it get instance. Once the bulb instance gets hold of the electric meter instance, it goes on and call the acquire connection method on the instance within its turn on method in order to consume power, and likewise the turn off method releases the connection using the instance release connection method. The singleton design pattern guideline dictates that to make a class singleton, it should adhere to the rules set for this pattern. First, it should include a field to hold a reference to its only instance. This field should be marked as private to make it hidden from other parts of the program, and also label it as static to indicate that this field only makes sense in the context of the class and have no relevance for individual objects. Next, this pattern dictates that the constructor of the class should be marked as private. This wipes out all the possibilities of creating an instance of this class from other parts of the program. But since we know that these accessibility modifiers do not make any sense in the context of its owning class, so now the only way left to come up with an instance of this class is to create it within the same class itself and then expose it to the outside world by introducing some public method as a mean to get hold of the class instance. And rightly so, here we introduce a public method and by conventions it is named getInstance. Inside this method, we first check to see whether the variable we declared earlier already holds a reference to an instance of this class or not. If it haven't, then we create an instance and assign it to the field. So next time this method is called, this class field already points to an existing instance. So this check invalidates and then the same instance is returned for each invocation to this method. One thing you may have noticed here is that we are only creating the instance of the class when someone requests for it the very first time. This way of creating an instance only when it is required is termed as lazy instantiation. But it has the consequence that if you are designing a multi-threaded application, then the get instance method is not thread safe in that case, as the request for the class instance may get originated from different parts of the program at the very same time, and the get instance method could come up with multiple instances of the class. To make the singleton class behaves the way it should in that case, we have to coordinate access to this method between threads by marking this method as synchronized. Another approach that makes the code simple and thread safe is to eagerly create the class instance during the field initialization and simply return that instance from the getInstance method. Let's now switch to the Eclipse IDE to see the singleton design pattern in action. Here I have created a singleton class that follows eager instantiation strategy. We created an instance of the class and later assign it to a variable of the same type. Then we mark the class constructor as private and further we expose a method getInstance to share the only instance of this class with others. We have also added some logging details to the acquire connection and release connection methods of the class to simulate the desired behavior. Next, we have a bulb class that actually depends on the electric meter singleton class for its actions. So to reach out to an instance of the electric meter class, the bulb class is making a call to the getInstance static method of the electric meter class and get back the only instance of that class. Once the object is made available, it further goes on and call the acquire connection method on the instance in its turn on method to simulate the behavior of consuming power required for the bulb to start emitting light, and likewise make a call to the release connection on the instance within its turn off method to disconnect from the power supply. Here, inside the main method that acts as an entry point for the console-based applications, we have created a couple of instances of the bulb class and further calling its turn on and turn off methods to make sure that things are working as intended. As an exercise, I would like you to pause the video now and create a console-based application and manually type the code shown here for each one of these classes. Then run the program and examine the output for details. This finally wraps our discussion on the singleton design pattern. I hope that this tutorial will help to better understand the intricacies of the design patterns in general and the singleton design pattern in particular. Before I say goodbye to you, I would like to request you to please subscribe to this channel for latest updates. Goodbye and see you in the upcoming courses.